Hey everyone, welcome back to Pepcoding. So in this video, we are going to solve our next question, which is count of subarrays with equal number of zeros and ones. So what we are given in this question is we are given an array that contains only zeros and ones. And we have to find the count of subarrays with equal number of zeros and ones, right? So let's just analyze this with an example. Let's suppose this is the given array and what will be our approach to find the subarrays which will contain equal number of zeros and ones? Like this is a subarray, this is a subarray, this is a subarray, this is a subarray. So many subarrays are there. How we can find this? So the first and the foremost thing will be while we'll first calculate the sum. Why are we calculating the sum? So if we have from this till this, the sum is equal to x, and from this till this, the sum is equal to x, right? So the difference between them, like this will contain equal number of zeros and ones because the sum is same. So the difference between them would be, of course, that subarray which will contain equal number of zeros and ones. So this was the example. So how we can do this? So first of all, we'll consider while summing all the elements in the array, we'll consider 0 as -1 and we'll consider 1 as +1. Okay, so we'll have sum. Initially the sum is 0, right? We'll write the frequency also, right? 0 came for the first time. So now let's just add up. For 0, we'll have 0 minus 1, which will be -1, which came for the first time, right? Next, 0 came. So now -1 would be -2, which came for the first time. Next, we have 1. So -2 plus 1 would be -1. So -1, which came for the second time now. So now we know that there is a subarray from this till this, right? So we write our count here. And what will be our count? This is our first subarray. So we'll have count as 1 now, right? Next, 0 came. We'll add -1 for the 0. -1 would be -2, which came for the second time now. And now we know that this is the subarray. So we'll add +1 one more time. 1 came and we'll add 1 for this. So -2 plus 1 would be -1. -1 came for the third time. So now we know that there is 2 subarrays. So this is the first subarray and this is the second subarray, right? So we'll add the count 2. Okay. Next, 0 came and we'll add -1. So -1 would be -2. So we have -2 and we have the frequency as 3 now, right? So now we know that till this one, 2 subarrays are there. So this is the first subarray and this is the second subarray, right? So we'll add 2 one more time. Add 2 here. 1 came, -2 plus 1 would be -1. -1 came for the fourth time, right? So now we know that there are 3 subarrays. So this is the first one, this is the second one, and this is the third one. So there are 3 subarrays now, right? We'll add the count 3. Okay. Next we have 1. So -1 plus 1 would be 0. 0 came for the second time. Now we know that only one subarray exists, this one, right? Which contains 4 zeros and 4 ones, right? So we'll add 1. Next, 0 came, and for this we'll add -1. So 0 minus 1 would be -1. So -1 frequency would be 5 now, and we know that 4 subarrays exist till this point. This is the first subarray. This is the second subarray. This is the third subarray. And we have the fourth subarray. Right? So we'll add 4 in our count. Right? Next, the 0 came, and we have -1 minus 1 would be -2. -2 came for the 4th time now, and we have, this is our first subarray. Next, what we have, this is our second subarray. This is our third subarray. And we know that 3 subarrays are there, so we'll add 3 now. Okay, 1 came, and we have -2 plus 1 would be -1. So -1 came for the 6th time, and we know that 5 subarrays are there till this point. We have 1, 2, 3, 4, and we have 5. 5 subarrays are there. Let's just add 5. Right? We'll add 5. 1 came, -1 plus 1 would be 0. 0 came for the 3rd time, and we know that 2 subarrays are there. First is this one, and the second is this one, which contains 1, 2, 3, 4, 5, 6, 6 zeros and 6 ones. So we'll add 2 now, plus this one, we'll add +1. 0 plus 1 is 1, which came for the 4th time, and there is no subarray now which contains equal number of zeros and ones. Till this time, there were many subarrays, but now we don't have any subarray, because till this point, equal number of zeros and ones were there, but now by having 1 in our array, there is no point till here from the whole that equal number of zeros and ones are there. So yeah, this was our count. We'll add them and we'll return them. So yeah, this was our approach. Let's just code it now. Okay, so we're given the function solution here. We'll first make the variable answer, then we'll make a hash map of integer versus integer type. And we'll give it a name as map equals to new hash map. Next, what we'll put in our map, 0 and 1s, right? Next, we'll make a variable sum initialize it from 0, and we'll start the for loop for int value, and we'll traverse in our given array. What we do, if the value is 0, then what we'll add in our sum? We'll add -1. If the value is 1, then we'll add +1. Okay. So next, we'll check if map.contains key if sum was already there, we'll increase the frequency, right? So answer plus equal to map.getSum. We'll update the answer also. Plus we'll increase the frequency in our map. Map.put sum comma. The frequency would be map.get sum +1. Okay. Next, what we'll have, else if it was not there, then we'll put the frequency as 1 only, right? So map.put sum comma 1. Yeah, this was to work. At last we would return our sum. Just return sum. Let's just run this code and see if it's correct or not. Okay, output seems to be correct. Let's just submit this code. Okay, something wrong in our answer. Let's just see. Okay, we have to return answer, not sum. You have to return the count, right? Which we have stored in our answer. Run this code. Now it should be correct. Yeah, 4 is correct for this one. Just submit this code. Okay. So all test cases passed now. So I hope I was clear with the concept, and thank you so much for watching this video. I'll see you in the next video. And don't forget to like, share and subscribe to our YouTube channel. Thank you.